Welcome. Hopefully you've all downloaded and prepared very hard for this session. Oh, no, I didn't put anything out there. That's right. Hopefully you're ready to relax and have a chill session where we do some typing and learn about the shell. So I want to thank the 9 folks who voted for shell in the Slack. I know there's a lot of stuff going on in the Slack and voting and stuff. Thank you. Outstanding. So I decided that we would do shell based on the 9 people 2 days ago who voted. I didn't prepare much because it was 2 days. And I'm sure you're all feeling, if not jet lagged, then like your head is crammed full of things. So my goal with this session, let's see, I wrote down some goals. Hands-on, interactive. Hands-on, I want you typing on your laptops, listening to what I'm saying. A little bit of a choose your own adventure. If I say something and you go, oh, that's immediately useful, see if you can follow along or do it with me. This session is mostly about exposing you to things that are out there so that you know that they exist, not that you understand how to do them. The nice thing about software engineering is it's done by computer scientists, which means computer scientists are always at their computer. And if you have a computer science degree, you know how to Google things, which means that some other computer scientist wrote the answer to your question on the internet, and the next person can find it. So everything I do today, I'll probably be doing a lot of web searching. But again, exposing you to what's out there, giving you the terms so you can search them yourself later. And these things that I'm talking about now, there's not really a computer science class on the shell. You don't go to university to do that. But you Google, you ask your friends, you chat with your colleagues, how do you solve this problem? I saw Ludwig on Tuesday used the watch command. I had never seen that command before. Looks incredible. So that's the first thing I'm gonna do right now is we're gonna look about watch. But I know some folks maybe had specific questions they were hoping to get answered, even maybe on Git or other things. If you had some specific questions you wanted answered, we have a huge number of experts in the back of the room. I'm gonna open the floor up to when we get there, to some general free type, free answer questions. And if you raise your hand, I'm gonna ask one of our experts to go and maybe sit with you and help you if you have a specific question to sit and get that answered and solve your problem. So if you're banging your head against some software engineering problem, raise your hand when we get to it and we'll have someone come and maybe answer your question. So if you don't have a question, think about it. But if you do, we'll try to solve it today. So again, there's lots of things to try. And so let's get started. So what is the shell? Well, here I am in my terminal app. So I think this is the shell. Maybe. The shell is a program that runs and asks me to tell it what to do. So if you don't know the command echo, that means just repeat after me. Hello, hello, echo, very useful. More useful if you have variables. Echo shell. What is my shell? My shell is binzish. There are many shells. None are better than the others, although some think they are. Everyone has their preference and everyone has the shell that they know. I started with bash. Most HPC clusters probably have a bash default. People who come from some other domains or from maybe a previous generation might like Sish or Tish. Those are C shell, and Tish is maybe the C shell. I don't know. T is for something. I personally like Fish, which is friendly interactive shell. The thing I like about Fish is that it automatically shows me what's coming up, what I've typed before. So if I type SSH, you can kind of see the last SSH command that I ran had all this long stuff with it. I can just go to that end of the line. Didn't work, but at least it ran what I ran last time. So that's something. Zeesh is very similar to Bash. The Macs used to come with a Bash default, but now they come with Zeesh default because Bash has probably not been updated in 50 years or something like that. Zeesh can get fancy, but if I type SSH, it's not showing me anything by default. And if I hit the up arrow, I have no Zeesh history, so it's not working either. Let's go over to Fish because that's where I'm most useful. So you'll notice that when I hit enter, I get this line of stuff. That's called a prompt. You will want to make your prompt look pretty. Maybe you've noticed some people had pretty prompts. Google how to make your prompt look pretty. I like having the time because I always, as the first part of my prompt, because I always forget to time my commands and I don't want to run them twice when it's taking a long time. I want to know. So not that the time updates, but I at least have some general sense of how long since I hit enter. And if you're typing things really fast, gives you a hint. Or if you're late to a meeting and you notice the time, that's very useful as well. Time, username, Loftair is the name of my machine. Little squiggly means that I'm in my home directory. If I ls, it looks like it's got some regular stuff. I don't really care about ls. I'm a computer scientist, so I do ls-al. I want everything in a very long list. Okay, that's a little more information. All these hidden secret dot files in Unix, POSIX, Unix, I don't know. If a file name or directory name starts with a dot, by default, it's hidden if you do a plain ls. But I like to see all these hidden things all the time because that's where applications put their settings or so put their configurations. Sometimes there'll be a .cache directory. If you do anything with Python or pip, it'll cache. When you download stuff from pip, it puts it in this hidden cache directory. So you blow out your home directory quota on your HPC machine and you go, where's all my data? If you look into that hidden cache directory, oh, it's got 12 gigabytes of NumPy or something. Anyway, so I don't like typing all that much because I can think faster than I can type, no matter how fast I type. So I have made some little shortcuts for myself called aliases. Again, Google, every shell offers aliases. So instead of typing ls-al, I just type la, and it shows me the same thing. I also always forget the shortcut pwd, which prints out your present working directory. I always forget that for some reason. So I made an alias called Marco Polo. And it's just fun. That's why I do it. It printed out my host name, kind of what system am I on. Sometimes you forget. And my full directory path. So not the little tilde, but the full path all the way from slash. A lot of working in the shell is spelunking through caves. I mean, the file system. You get lost. You don't remember where you are. You got to be typing Marco, where am I? LA, what am I looking at here? CD into my projects directory. What's going on in there? I am typing these things all day, every day, all the time. Where am I? What am I looking at now? Where do I need to go next? With other things like Git, or anything where there's, state kind of changes behind the covers. Git has a git status command. I type that all the time. What's the status? What's going on? What did I change 2 minutes ago? I'm a goldfish. I don't remember. My brain, I try not to keep those things in my brain because the computer knows better than I do. So I know the command to very quickly figure out what the state of things are. Git as well, if you get into Git, I know some people are interested, lets you make aliases. So all these things that you're running on the command line, most of them let you make little aliases to make your life a little easier. So I hope you all have a terminal up and are exploring and typing away. Let's talk a little bit. You'll notice my prompt changed. I CD'd into my projects directory. My prompt changed. Some people like long paths. Some people like full paths. I just like the one word. You can change it to your heart's content. All my configurations I keep in a Git repository, so that I can put them on new computers and I can share them with you all. You can find them. Oh, this is so tiny. github.com/Gonsie, Gonsie. That's me. And my .files repo. If there's any setting you see that you like, I'm storing it in this repository. My bash settings, my bash aliases, and my Marco alias right there. I have these other ones. I don't know them all, but they're there. And my fish, because I use fish all the time. Yeah, that's so tiny. Let's see, fish functions. LA. I don't know why that had to be a function. Maybe fish didn't do aliases. I set it up once and then I use it again. And the way I figured it out was I Googled fish. If you're interested in a shell, it has a very nice documentation page. And I made it work once. I put it in a repo. I copy it on every computer I run on, including supercomputers. Then my commands are there and nice, and I don't have to remember how to do that again. Okay. So let's talk a little bit. I'm going to walk through the fish documentation a little bit because fish is a shell, and this documentation explains what is a shell, which is kind of what we're talking about today. Here are some useful commands if you haven't seen them already this week. CD, change directory, ls, list files, man, which means display the manual page about a command. MV is move, CP is copy. Open, very useful all the time. If I want to open a Finder window, at least on a Mac, you can type open and it pulled up this window here. Or if I wanted to open a particular file, open my .files apps and headshot. Headshot. That's very old. All right. Open's a good command. Less is to display the contents of a file. There's less, or there's also cat. I usually prefer cat. This is my current SSH config. Cat means concatenate it with the screen. It just printed it out, got me back to the prompt. Shell commands. So the first thing I type on the shell line is a command. They take arguments, and that's the options, flags, inputs, things that you're reading on the command. Some commands are little binary, actually applications, little executables that go and get run. So cat is an executable. I think echo, it can be an executable. Sed or grep or awk, some of those more text manipulation things are executables that go and get run. Your application that you compile and then you do ./a.out, that's a thing that gets run. But there's also built-ins, so there's syntax and commands as part of the shell, built-ins. Those are things like for loops, if statements. So if you're ever doing anything and you need a for loop from 1 to 10, hopefully you're not typing out 1, 2, 3, 4, 5. You figure out the shortcut for your shell, seek 5. Okay, I don't know, is seek built into fish or built into bash? Is it built into fish or is it a command? I don't know, let's check it out. Which seek. user bin seek, so it's not something that is built into the shell. There's an executable here. So if I LA which seek, it gives me all this information. Owned by the root user in the wheel group. Last updated on May 7th. User bin seek, a function. An executable thing. File. All right. This command probably didn't work if you typed it out in Bash because it has those parentheses. So if we type it in C, which would also work for Bash, you would have to use what did I do? Which seek, and then I did LA. Do I have LA? Yep, LA, which seek. So what's happening here is with the little backticks. So this is what works in Z-Sure Bash. Backtick means execute what's inside the backticks, and then take the result of that execution, put it here on that line, and run the rest of the line. So again, which seek, SEQ, returned this user bin seek instead of typing LA user bin seek. I can just type LA and then have the shell run the command which seek, get that path, and then LA it. Making sense? All right. Functions. Sometimes you want to do, so I was showing you earlier, I had LA be a function. I had defined it in my dot files, cat dot files, my fish files, my function, my LA function. I made it a function even though it's just an alias really for this ls command. But if I wanted to make it list, and if I wanted to make it more complicated, I could do a function. Let's see what other functions I have. So let's LA my fish functions. So I wrote this function called catl, which is a way for me to cat a specific line of a file. Because sometimes I just want to see what the 10th line is, but I don't want to cat the whole thing and then take the tail of the whole thing. Like there's a couple of ways to get at that line, and you could probably pass a command line option to cat, but I don't want to be typing man cat all the time and reading this. I don't think there was a way. Maybe so I wrote this function called catl. So let's look at what it looks like. It has these little vertical bars. These bars are called pipes. So this is a complex command that first it does cat, and hopefully you all can read that. First it cats an argument. Then it runs the head command on the output of the cat. With a dash and then this number. Then it pipes that all to tail and gets the last one. So let's see. Let's cat. What do I have going on in here? Let's cat the README that I have in my .files repo. And let's try catl10. What's the 10th line? I could also, if I break it down, so I had, first I did a cat, then I passed that off and did a head 10, which cuts off just the first 10 of what you got before. Alternatively, I could have run head 10, and I think head 10 .files readme. That would have worked too. I could have skipped the cat and the pipe,
and just did head 10. And then tail of a file. Let's see, tail takes some number. Let's do man tail and see what's going on. Display the last part of a file. By default, I'm sure it picks some number. So if I had just done tail dot files readme, head shows me the first 10 lines here. Tail shows me the last 10 lines. Let's see. Head 10, pipe, tail 1 gets me, no, dash 1, excuse me, gets you that last, that's the last one line coming out of this command. Make sense? All right. Heads and tails and cats and mans and what else can we think of? We did pipes. That's always fun. Let's talk a little bit about the things that I'm typing. So hopefully you all know Control C. So if I type something and realize it's gibberish and I don't want to hit the back button, that's too slow, I hit the Command and the C, and that means stop doing that thing. Cancel it. Cancel it. If I'm running a command that takes a long time, like there's a sleep command and I could tell it to sleep for a while, and I would really like it if my prompt could come back so I could keep doing some work, I can just hit Control C and cancel that sleep. And here's my prompt and I can keep doing work. So if you ever decide that you run something and you think it should be fast and then it's not fast, you can Control C it and just say, okay, stop, please. What else? Sleep. So the sleep function just does nothing for however long you tell it to do nothing for. It sleeps. Why to do it? That's a great question. So oftentimes in HPC or computer science, if you put in too many requests at the same time or too quickly, the computer on the other side of the whatever you're requesting breaks. Right? If everyone tries to load github.com at the same exact time, or google.com, or there's some picture on a website or a news site that everyone wants to look at the same time, that's called a DDoS attack. If everyone in the whole global world tries to load it at one time, usually the web server can't serve it up fast enough. You can DDoS your own machine because your computer can try to execute commands faster than it can respond. And that happens a lot in HPC where, say you have a file system that's on a different node. The file systems are also often on different hardware than your compute. If you try to ls files in the file system from 1,000 million processes all at once, if you try to ls the same directory, it will break. Or you could put it in a loop. People sometimes will try to ls a file and say, does it exist yet? Or did it update yet? When did my output get, if maybe they write to a file when they're done with their application running, does that file exist yet? Did it change? Did something change? If you put that in a loop, you'll break the file system or you'll break something on the other side. So you can sleep means check it, wait a bit. You can sleep there. So it'd be like ls, what's going on? Wait, sleep. So sleep is just like do computer things slower at human speed instead of as fast as the computer can go. So here's an example. Let's write a for loop. And again, this is in fish syntax, slightly different than bash. For I in seek 10, echo I, sleep 1, end. So just doing a little bit slower because of that sleep. as opposed to printing it all out faster than you can see. Yeah. And even if I do this for loop, I can hit Control C in the middle of it, cancel it if it's going too slow for me. All right, Control C. Another option is called Control Z. Jobs. I guess that didn't work. So Control Z moves something that's running and puts it in a pause state. So if it's taking up your command line, let me try that for loop again, a little bit slower. And let's have it sleep for 10 seconds, and we'll have the sequence only go till 3. 1. All right, this is taking too long. Z moves it to the background. As soon as I hit Z, immediately 2 comes up, immediately 3 comes up if I keep hitting Z. So it took that sleep process, that 10-second sleep process that was running, and it told it, stop running, but don't quit. Save your state, save everything that you're there. You're just not running at the moment. And if I run the jobs command, it tells me all the processes, all the sub-processes even, that I ran, and I stopped with that Control Z. So it didn't kill it. It didn't, the command didn't quit. I can bring those back forward again with the FG command to bring them to the foreground. I could bring job number 1 to the foreground. It was I think I have to use %1. Sending job 1 of sleep to the foreground. It's not going to do anything interesting because it's just sleeping. But bring those all to the foreground. Bring 2 to the foreground. Jobs. I have all these jobs. But maybe I don't actually want to bring them to the foreground and do want them to go away. I can run the kill. I don't know. Maybe that will work. Jobs. So I ran kill %7. That gave me a job number. This job number is different from a process ID. Typically, let's see. PS can be how you look at processes. No username Gonzi. That's because I'm on the wrong computer. I don't know how to run this command, but I know it does something that I need. So let's see what I should really be doing. Let's do man PS. PS process status tells me about processes that are going on, blah, 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 blah. Sometimes at the end, there's really useful examples. Not here. All right, so you could read processes. Oftentimes when I get to these really complicated things, I'll go and Google. I'll say, Google, show me processes owned by a user. And then if that's still not giving me what I want, I'll add the keyword bash or the keyword Unix. And that'll get you usually a little walkthrough or template of what's going on. All right. How are we doing? Okay. All right. One last thing that I want to show you all how to do is how to enable tab completion and up arrow completion searching history. So this is the secret magic keyword that you do. You have a file called .inputrc. You put it in your home directory. You fill the file with these things, and then it magically works. Somehow this set show all if ambiguous on means even if I type CD with a lowercase p, it auto completes with uppercase files, so you don't have to get the uppercase, lowercase, that ignore case, the ambiguous works. So these are just things that you can copy. Again, Gonzi, github.com/Gonzi. You can find my dot files and find this as well. But the history, this /E thing A is an up arrow. That's like the code that comes out of the keyboard and goes to the terminal, is this weirdo code. And this is how you get it to search history, so that when I type this up arrow, the terminal actually gets this kind of sequence code and knows to give me my history just by typing up arrow or down arrow. Or Control P, Control N. Control P and Control N are GNU read line key commands. There's also SSH. Control E gets you to the end of a line. Control A gets your cursor to the front of the line for a lot of Unix things. And why is that? It's called GNU read line. It's hard to remember that and Google it. It's hard to Google how to move my cursor to the end of the line with one key command. Control E, Control A, GNU read line inputs. Those are the keywords. Okay. All right. So I've been rambling for half an hour. Hopefully you found something exciting. Oh, the one last thing that I think you should do is make sure in your prompt, who here uses Slurm on their HPC, right? And who here uses salloc to do interactive allocations? Okay. Who here has sometimes forgotten whether or not they're inside an interactive allocation? Yeah. You can put in your prompt that it will show you your job ID when you're in an allocation. If and only if you are in an allocation. So I'm going to go ahead and get logged in to a computer where I have that set up, and I'll show you what my prompt looks like there. But in the meantime, if you have a question that you wanted to get answered about Shell or about some other software engineering topic, please raise your hand. And folks at the back of the room who are typing and working, please pause for a moment, my hands-on helpers, and stand up and help people answer their questions. So please raise your hands, and we're going to try to answer some of your software engineering questions. Or if you think you have a question for the whole group that you want to see me walk through, I'm happy to hear those as well. But I'm going to try to get logged in and show you what my prompt looks like inside a salloc. All right? Everyone feeling chill? That's good. Anyone with a question? Just too much? Yeah.
You said you had
Sure. So she asked about how do you go between machines, and there's two schools of thought. One school of thought is have no customizations. That way you don't need to do anything to get up and running on a new machine. Lots of people do that. I, on the other hand, love my pretty colors. And actually, I love my pretty colors. I love my fonts. And I usually actually use a dark color scheme. Light is maybe showing up better here. I usually use a dark color scheme. I use Emacs with lots of pretty colors and customizations. Ooh. Like this. Pretty. I just like pretty things. And so I have put quite some effort into a Git repo that holds everything and documentation for myself to get it up and running. So every time I get a new computer or get a travel computer from work, I'll read that documentation. If something's missing, I add it to the documentation. And I keep track of the steps that I repeat all the time. So it's my .files repo. Let's make this bigger. There's a README here. And if you prefer a web interface, again, github.com/Gonzi has all of this. So this README is pretty good. It'll get you pretty far. The key to a lot of folks, so all my configuration .files live in this repository, but some people will make that repository exist in their home directory. I like to make it exist in two places. One in I have a project, and then I actually install my .files into my home directory, which means I need a little bit more complicated logic to, if something gets out of whack, see if I need to bring it back to my repo, commit it, and like save that thing. So it's a little bit of a complicated workflow, but that's what I use. So just even having a Git repo, even if it was in your home directory, let me show you that. Let's show you my home directory. Even at this small size, all these purple ones are actually symlinks. So they're the symlink. So the .bash profile, that file has to exist in your home directory for bash to find it, but you can make a symlink to some other place. And I symlinked it to this config directory into my deep kind of repo. So you can have a repo that exists and use symlinks to go into that repo and have your files there. Does that make sense? Yeah. A symlink? Oh, for sure. For sure. It's the ln command. I know that. Man ln. Ln link. Or I guess, I could type link. I didn't know that. Link, source file, and target file. So with several of these commands, you kind of memorize an incantation that works. The incantation for ln is ln-s, make it symbolic. The file system allows for different types. There's hard links, soft links, blah, blah, blah. The other ones don't matter. Symlink is probably what you want, and what most people know. And, okay, what was it? Man, ln, source first, target last. So ln-s for symbolic. My source can be we could say my projects .files directory, and let's put it on my desktop. So let's see what's on my desktop now. I don't know if there's a way to make that bigger. There we go. Text size. Maybe a little better. Maybe you can see that. But here is that symlink I created. If I double click it, it's going to say it can't be found. The problem is, let's go and look in the terminal. And let's LA my desktop folder. It has .files. The little @ means it's a symlink, and it's pointing to, I think it means it's an executable symlink. The arrow, it says where it's pointing to. It's pointing to projects.files. The problem is desktop doesn't have a subdirectory called project to go into. My link was not, they're relative. Exactly. So I can rm my desktop .files thing and try again, lns/projects .files. Oh, I don't know what that did. Oh, I didn't even give it. I gave it one thing, just one, this one here that I ran. I didn't give it a second command. I didn't give it a second target, but it made it anyway, and it put it where I was. Put it automatically in dot. Ellen, let's put it on my desktop. And now that works. That better formed ln command. Make sense? Okay. Other questions? Or even if folks have Git questions that they wanted to try or anything, happy to talk about that. Let's get logged into my RZ Slick. Who uses SSH? Who understands SSH?